Hello friends, welcome to the Formula Engineering classroom. And in last lecture we'll discuss about the stream function. Now in this lecture we will discuss about the potential function, and we'll see what is the sense or what is the meaning of potential function. So to understand the potential function, we'll start from the definition of the stream function. Like we provide the definition of stream function, that is u is equals to del psi by del y and v is equals to minus del psi by del x. We discussed it a lot in the last lecture. Now from there also we can also say that there is a d psi. We write that is d psi is the total derivative of psi when the psi is the function of x and y. We write that there is del psi by del x dx plus del psi by del y dy. Okay, and we write that there is d psi is equals to 0, that is when psi is constant. So we write that is del psi by del x dx plus del psi by del y dy equals to 0. And when we replace this value of del psi by del x and del psi by del y by the function of u and v, so we can write this is minus v dx plus u dy equals to 0 here. Okay, so by using this one, when we try to find out the slope, so slope we can write out that is dy by dx. So in this case we can write down that is dy by dx. So when this term is going to be over here, that is this is minus u, minus minus is going to be cancelled out. So this term is going to be simply v by u. Okay, so we can say that this is the slope of streamline. Okay, and then I'm defining by m1. So we are defining that m1 is the slope of streamline. Now we required some line that are exactly perpendicular to streamlines. Okay, now we have to define the lines that are exactly perpendicular to streamlines, and we know from our previous mathematics that is when the two lines are mutually perpendicular to each other, then their slope m1 and m2 will be equals to minus 1. Okay, so now as we are saying this is m1, so m2, so from here we can say that there is m2 will be what, that is it is providing that is m1 m2 equals to minus 1. So we can write down that is m2 is equals to minus u by v. So if m2 is like that, then by multiplying m1 and m2 you can write that is v by u multiplied by minus u by v. It will provide, so u is going to cancel out here, 1, v is also going to cancel out here, this is providing 1 here. So by using this one we can say that this line of slope having minus u by v will be perpendicular to the streamline. So we can say that this is equals to dy by dx, or this is the slope of that line. Okay, so by using this one we can write that is this is a minus u dx equals to v dy, or we can write this is when this is going to be here, this is going to be minus here, minus minus is going to be cancelled out here. So we can write this is u dx plus v dy equals to 0. So this line will be perpendicular to this line. Now if let's suppose I'm saying that is phi is some function and it is function of x and y, then the total derivative of this function we can say that there is d phi will be equals to del phi by del x dx plus del phi by del y dy. Okay, so if phi is some function, the total derivative of this function will be like that. Now if I'm saying if phi is 0, obviously when the phi is 0, or in that case the change in this function, that is change in this function is going to be 3. If I'm saying phi is constant here, so change in this function is going to be 0 here. So when I'm saying phi is constant, the change in this function is going to be 0. So from there we can write this is equals to del phi by del x dx plus del phi by del y dy equals to 0. Now equating this equation to this equation, from here we can write that is the term with dx, here is del phi by del x and here it is u. So we can say that there is u is equals to del phi by del x. Similarly, the term with dy is del phi by del y and here it is v. So we can write this is del phi by del y. Okay, so this is the definition of potential function. Here we can say that is phi is potential function. Here we can say that is phi is potential function. Okay, we are saying phi is potential function. So how this function is behaving? So we are simply saying that is the derivative of this function with respect to x is providing the velocity in x direction, that is positive x direction, and the derivative of this function with respect to y is providing the positive velocity in the y direction. So this is how the function is behaving. And this function we are saying that is when we are saying phi is constant, so this is defined as equipotential line, and this line is such that is these equipotential lines are perpendicular to the streamlines. Okay, because we drive the function such that here that is this is providing that is this line is simply perpendicular of this line, and through this one we drive this one, so we can say that there is equipotential line. So we are saying when phi is constant, they are defined as equipotential line. Okay, and we simply define this one now. So in this case, this definition of phi or potential function is based on this definition of psi. As I told you in the previous lecture, that is the definitions of psi can be different. Like if in this case we are writing that is u equals to del psi by del y and v equals to minus del psi by del x, we can also say that is psi is u equals to minus del psi by del y or v equals to plus del psi by del x. For that case, the value or the definition of phi is also going to change. Means when we are saying that is if we are saying defining psi says that is if u equals to del psi by del y and v equals to minus del psi by del x, for that case the phi will be simply we can say that is u equals to del phi by del x and v will be equals to del phi by del y. But if we are saying that is if psi is, so this is one definition here we are providing, and if we are saying u equals to minus del psi by del y, here I'm changing the sign here, you can hear I'm exchanging the sign here, and v is equals to del psi by del x, for that case the phi will be look like u will be equals to minus del phi by del x and v will be equals to minus del phi by del y. In that case the phi will got negative sign in both case if you are changing the definition of psi. So both the definitions are correct of the psi and phi, but the respective value of phi is also going to be changed in that case. Okay, so now as we provided the definition of phi, that is it is simply when we define that is u is equals to del phi by del x and v is equals to del phi by del y, and we define the psi that is u is equals to simply del psi by del y and v is equals to minus del psi by del x. Okay, so we will use this definition because this definition are universally adopted. Okay, so we will use this one. Now, so as these two line, that is streamline and equipotential line, are perpendicular to each other, so they are used to analyze the fluid flow patterns. How we can say that? So let's suppose if I'm saying there is a tank here, I'm considering a tank over here, and some pipe is attached to this tank, and let's suppose if I'm saying these are the streamlines along which the flow is happening here. These are the streamlines. Sorry, this is not straight, but okay. So these are the streamlines along which the flow is happening. So we know that is for each streamline there is one stream function, and that stream function is simply constant. So if I'm saying this is psi1, so for this streamline this function is constant over the streamline, that is psi1. And over here let's suppose n streamlines, so if for this one I'm saying psi n is the value of stream function, it is also will be psi n. Now, so potential function will be perpendicular to these lines, so it will look like this one. Here it is that I'm saying this is phi 1. So in this case this phi 1 is throughout same over this potential line, and it remains constant over here. Okay, similarly there are number of potential lines everywhere, they are perpendicular to the streamlines, and you can see here there is a net system by the use of stream function and potential function. So that this is the nth equipotential line, and here the value is of potential function is phi n. So this is defined as flow net. This is defined as flow net, this complete system. This is by the use of stream function and potential function. So by the use of this flow net we can analyze the flow patterns of we can analyze actually the flow system. How can we analyze? So let's suppose if we are considering this box over here, so we provide the definition, that is if you want to calculate the discharge between two streamline, in that case that discharge will be simply the difference of their two stream functions. So for this streamline and this streamline, the difference of these two stream functions, this one and this one, will provide the discharge between these two streamlines. So let's suppose if I'm saying that the flow of q amount is entering between these two streamlines, so obviously q amount of fluid is going to be exit in this case of these two streamlines, because the stream function difference between two streamlines will remain always same here. Okay, so this is how we are defining the streamline. Now this is higher potential value and this is lower potential value, so obviously in this case the flow will happen from the higher potential to lower potential values. Okay, so the direction of flow will be this one. So the flow direction will be along the streamlines and it is perpendicular to the equipotential lines. And we can say that here you can consider here for this box here the distance between two streamlines is more and here it is less, but the discharge through this one is same. So as the discharge is same here and here, in that case if the area is more, in that case the velocity at this section of the flow will be less, and here the velocity at this section will be high compared to this one, because here the area is going to be less in this case. So there is so many information we can get through this one. Similarly, if we are considering a stream tube or if you are considering a flow through a tap, so the stream flow we can assume like that, that is it is look like this one. So these are the streamlines. Actually we are considering a flow from a tap that is moving in downward direction like this. Okay, somewhere over here is some tap here. So we are defining this is, let's suppose psi 1 is the streamline here, and similarly this over through this one we are saying psi n, number of streamlines are n here, so this is psi n here. And in that case the potential function will look like this one, it will be perpendicular to the streamlines. So this is our phi 1. Similarly it is here, it's like that in this case. So this is the flow net of like this. So this is phi n over here. Okay, this is the potential function. So this is the flow pattern when the fluid is moving or fluid is falling from a tap. So in that case the fluid is moving along the streamline, but it is perpendicular to the potential. Okay, it is perpendicular simply equals to the potential function here, or this is perpendicular to the equipotential line. So that's why we require the flow net. So this is also flow net, this is also flow net here. Now second information we can gather from the potential function, like we discussed in the stream function. So let's suppose if we are considering the rotational equation, that is omega z, we discussed that. So this is 1 by 2, this is, so we define this is del x minus del y over here. So this is del v over here, this is del u over here, this is del v. Okay, so this is del v by del x minus del u upon del y. Now we know that is from the definition of potential function, that is u equals to del phi by del x and v equals to del phi by del y. We'll put that value here. So we will write this is 1 by 2. So in this case this is v here. So definition of v, we can write this is del 2 phi over del x del y minus del 2 phi over del y del x. So both the values are equal in this case. This is going to be cancel out and this whole value will be equals to 0. Means we are saying that is omega z is 0. Means if potential function exists, the flow will always be irrotational, because in that case it will always satisfy this equation and it will provide always 0 over here. So here we can say that if potential function phi exists, the flow will be irrotational. Okay, point is clear. Now this is our second point. Similarly we can define our third point. Actually our first point was we provide this one, that is streamline and potential line perpendicular to each other. Third point, so we write for the streamlines, or simply we write the quantity equation for the steady incompressible two-dimensional flow. Again I'm writing here, that is del u by del x plus del v by del y equals to 0. I also wrote this equation for the streamline and we will discuss this topic next to this topic. Okay, so this is the quantity equation when the flow is steady, incompressible and 2D. So let's put the value of u and v here from the definition of phi. So this is del 2 phi by del x square plus del 2 phi over del y square equals to 0. So this become the Laplace equation. So we can also write this one like this is del 2 phi equals to 0. Okay, so means if phi is existing and the value of phi is such that it is providing this value equals to 0, that is if phi is existing and if phi is satisfying the Laplace equation, then the flow will be continuous. Means it's not giving the guarantee that is flow will always be continuous. It is simply saying if the potential function exists and if it's satisfying the Laplace equation, in that case the flow is going to be continuous. But it is providing a guarantee in case of rotationality of flow, that is if phi exists, that then the flow will always be the flow will always be irrotational. So it is providing the guarantee in this case, but it is not taking the guarantee in this case. It is simply saying if it is existing and if it is satisfying the Laplace equation, then the flow is going to be continuous. Okay, so this was our potential function. Okay, now let's see some problem. So here I'm taking an IES problem or engineering services exam problem here, and this is the problem of engineering services ESE exam. This is ESE exam of 2010. Okay, and in this case it's saying if stream function psi is given by x square minus y square, then what will be the value of velocity vector? That is, what will be the value of velocity vector at point 1 1? Okay, this is the problem. Means problem is that if the psi is given like then what will be the value of velocity vector at the point 1 1? So this is very easy problem, we can solve it directly. So we know that is, by the definition of psi we can say that is u is equals to del psi by del y. Okay, so we can differentiate this with respect to y, so we can write this is del by del y, x square minus y square. So sorry, this is y here, not x here. So by the use of this one we can write this is equals to minus 2y. Similarly, we can write that is v is equals to minus del psi by del x. Okay, then we can write this is minus del by del x, and we can again differentiate this one like that. And by use of this one, we can say that this will be equals to minus 2x. So we know the value of 2x and 2y. So at point 1 1, so at the point 1 1, u will be equals to, so this is equals to minus 2y, so in this case y is 1 here, so this is minus 2, and v is equals to minus 2x, so x is 1 here, so this v will become minus 2. And as we know the magnitude of u and v, we can find out what is the resultant velocity v, so we can write this one, this is u square plus v square. Okay, so this is whole root of minus 2 square plus minus 2 square. So this is simply equals to, what I'm writing here, this is simply equals to 4 plus 4. And by solving this one, we can write this is equals to 2 root 2. So this is the answer of this one. You can see here the problems are very easy in the IES examination over the stream function and potential function. Okay, let's take one more problem here. So in this case, we are saying that is, if u is equals to 5x cube and v is equals to minus 15 x square y, then what is the value of psi at the point 1 2? Okay, what is the value of psi 1 2, and we have to find out this value numerically. So u and v is given, and we have to find out the numerical value of psi at the point 1 2. So again we know that is d psi we define that d psi is del psi by del x dx plus del psi by del y dy. Okay, as you put the definition over here. So we know that is del psi by del x. By the definition of psi, we are putting that is u is simply equals to del psi over del y, and v is equals to minus del psi by del x. So we can say that there is del psi by del x is minus v. So we can write this is, that is d psi simply is, this is minus v dx plus, so del psi by del y we can find this is u dy. Okay, so we have the equation of d psi in terms of u and v. Now we can put the value of u and v here. So v is given by minus 15 x square y. So there is also minus here. So negative is going to be positive here. So we can, this is 15 x square y dx plus u is given 5x cube. So we can write this is 5x cube dy here. This is our dy. Okay, now take a look closely here. So in this case we are saying this is differentiation, this is 15x square y dx, means after the differentiation of this one we are getting this value. So before the differentiation we can say that this function was like 5x cube y. Okay, this before the differentiation the function was what 5x cube by y, because after differentiation when the 3 is going to be in front of 5, that is going to be multiplied, that is 15, this become x square, this is simply y dx. So now in this term, in this case, this is after the differentiation with respect to y, because there was initially y here. So after differentiating with respect to y, we are simply saying this is 5x cubed dy. Okay, so we both these functions can be rearranged in a set, and we can say that it is like that. It is like 5x cube y here. Okay, because when you differentiate this one with respect to x, then we'll say the value will be 15, that is 5 into 3, 15 x square y dx, that is this value, plus then we differentiate this one, so we'll say this is 5x cube dy, that is this value. Okay, so we are having, that is d psi is equals to d 5x cube y here. Okay, so we can integrate this one, and by integration we can say that there is psi is simply equals to 5x cube y. Okay, so we know the value of psi here, that is psi is equals to 5x cube y. We are having x is equals to 1 and y is equals to 2. So at point 1112, so we can say psi is 5 1 cube into 2. So this value is going to be simply 10 here, and this is the answer of this case. Okay, so I think the stream function and potential function are clear. In the next lecture, we will discuss about the quadratic equation, and we will finish the kinematics of fluid, and after that we will start the fluid dynamics. That is also very much important topic from the GATE IES point of view, from the fluid mechanics. And if guys, if you are liking the lectures, then please like the videos, subscribe my channel for more updates, and please comment your doubts and share the knowledge as much as you can. Thanks for watching. See you in the next lecture. See you soon. Take care of yourself.